Hey friends, welcome to Make Anything. It's Devin here, and today we're back with a pretty exciting video where I'll be showing off a few different projects that are all really cool and have very little in common, except for the fact that they were all created with this Snapmaker 3-in-1 3D printer. So this is a machine that I actually unboxed on a live stream over 2 years ago, so it's been a while. And well, since then I pretty much only used the 3D printer function. And it does create absolutely beautiful 3D prints. You'll see some more of those today. But the thing is, I never really tried out the laser and the CNC modules, which are the other two of the 3-in-1. So that's kind of ridiculous, right? The thing is, for the longest time, I considered 3-in-1 machines like this somewhat impractical because, well, for example, a CNC produces a lot of dust when you're carving things out, and then you've got the 3D printer, which is generally meant to operate in a pretty clean environment. So the idea of putting laser and CNC and 3D printer together sounds really cool, but I didn't think it would actually make sense in real life. Well, this year, Snapmaker funded the Snapmaker 2.0 machine on Kickstarter, raising record numbers, like every 3D printer seems to do, but people were really excited about it. I think it looks really cool, and so I figured it's about time I try out the entire suite of the Snapmaker tools. Today we're gonna start out with the laser module, then we'll do some CNC stuff, and then we'll finish it all off with some really cool 3D prints and some special tricks I pulled with that as well. But yeah, let's go ahead and attach the laser module, and you'll see just how easy it is to swap between these different things. Cool. So to get started, let's go ahead and remove the print head first. We'll just unplug this coiled cable. And then on the back here, you can see we have these M4 screws that are holding the module into place. So we've got 2 on the top here, and then 2 underneath as well. Make sure to hold the module while you're removing that last screw, but there you go. It pops right off. And then we can just grab the next module. We've got the 1600 milliwatt laser, and it's got the exact same form factor, so we really just put it in the same position and put those screws back in. And now our 3D printer is a laser engraver. Pretty cool, right? The one other thing we'll do is swap out the bed here, since we've got the heated bed attached for the 3D printer. Technically we could keep it on, but we're gonna swap it out for the aluminum plate, which has some additional holes for mounting screws, and that'll let us hold down our pieces. So we'll put those 4 screws back in, and they're a little bit tough to reach for my big hands, but no big problem. It screws on there nice and sturdy. There's no leveling here. It just goes on flat because this thing is engineered so precisely. Now I can go ahead and add these little M4 screws, which are basically going to be some mounting points to place down my piece. For this first project, I just want to laser engrave some paper. It's probably the simplest thing we could engrave on, so I'll just use these 3 screws to square up my piece of paper on the laser bed here. I don't really need to screw them down or anything, I kind of just push them into place. And now I'm going to open up Snapmaker Lumion, which is their open source software, which has tools for all the functions, CNC, 3D printing, and laser cutting, which is the one we're going to use here. And I'll bring in this little image I've already created earlier. And it's just this little black and white JPEG, which I want to include with the little piece of paper that I sign and write a message to when people buy my 3D prints. So here's the image, and as you can see, it's placed on top of this grid, which is measured out by millimeters. I know my pieces of paper are about 88 millimeters wide, so I'm gonna have to resize this image. I can grab the corner, hold shift, and shrink that down to maintain the aspect ratio. I think that's a good size. And then I can center that between the origin here, which I'll make the corner of my paper. And I know the other corner is gonna be over at 88 millimeters to the right. So I'll just center this in between that 0 and this 88. So that's like 9 millimeters on each side. I'm just roughing it based on this grid. I suppose I could use the shape tool and create a rectangle to really know the size, but I think this will work. So that's in place, and over here we've got a few different processes. We do want this to be black and white, although there's also a vector option which would outline the black images, good for cutting things out. And then there's grayscale, which alternates the power of the laser to create images with multiple values. But in this case, we just want the laser to be either on or off. It's black and white. So we'll select black and white, and then we can go down to process, and this software will create a preview of what our laser is going to be drawing. So you can see the individual lines and passes that the laser will be making. This looks a bit scrappy, but we can go over to the density here and increase it to the maximum of 10 dots per millimeter. So that'll make the lines a lot closer together, and as you can see, that immediately makes a big difference. Now we can make out even the tiny little circle here for the Make Anything logo. We'll see how that actually translates to real life, but for now we'll generate the G-code and export that to our flash drive. The flash drive plugs straight into the Snapmaker printer, so we'll make sure to have our safety glasses handy. Then we're going to go ahead and start by setting our origin. So to do that, you'll switch to jog mode, and we'll start by lowering the Z-axis until the laser is pretty much focused. So as you can see, that laser is basically creating a vertical line right now, but the closer and closer we bring it to the paper, the more in focus it becomes, and eventually it will become pretty much a single dot. There we go. At this height, we now have a really fine point, and if we needed to, we could focus the lens manually here as well by turning that metal ring, but this really looks great. So now that we have the Z-axis honed in, we'll move the X and Y to the very corner of that piece of paper to match the origin as we set it in the software. So there we go, that's pretty much the corner. Now we can go ahead and select Set Origin so that the machine will register this as the 0 point. Now we're ready to burn, so we're going to go to the files, select that file we exported from the software. And what's interesting is I have G-code files on this flash drive as well, but the Snapmaker seems to realize that we have the laser plugged in, so it only shows us the laser file. It's a small detail, but that just shows the consideration that Snapmaker put into this machine. So let's select that, hit start, and immediately the laser goes to work. So make sure you have your glasses on at this point. And it's also a really good idea to have this near a window with good ventilation. I've got my HEPA filter right next to it as well, because, well, we basically are burning this paper to create our image. And of course, to the naked eye, we wouldn't want to be looking at this laser. Even from the video, you can tell it's incredibly bright, and it can definitely blind you. But through the miracle of video technology, we can watch the laser as it's engraving its image. And here I am showing it in real time. This is the default speed. I think we could speed it up a bit, but this is doing a great job of creating a really nice dark image on this paper. Here's a super close-up look at the smallest details that are being lasered here. And you can see the individual laser pulses, especially at the bottom of the circle of the logo there, but for how tiny it is, I was really impressed with the level of detail that we can capture with this machine. We can definitely make out this Make Anything logo here. Man, I could watch these lasers all day, but here's the end result, and it takes about 4 minutes to create this small image, which looks really clean. And yeah, I absolutely love how it turned out. And I was able to make a whole bunch of them in about an hour or two. And it's really not much work at all, because besides putting the paper in place and hitting start, the machine does it all. So the laser works really well on paper, but that's really the bare minimum of what it should be able to do. To try something a bit more exotic and perhaps challenging, I decided to do some engraving on leather. So after running this quick test on a piece of cardboard, I cut up some leather and I just taped it down onto the build plate here. And honestly, the bed doesn't move really dramatically while it's laser engraving, so I probably didn't even have to tape it down, but it's probably a good idea just to make sure nothing moves. I'll go ahead and do that, and then I'll start my file. So right off the bat, using the same exact settings as I used on the paper, we can see that this is coming out really nice. It's creating a really dark image. And this is really exciting. It looks super cool, but I will say the smell of this was absolutely awful, which I guess makes sense since we're burning animal skin. So in the future, I will strictly be engraving leather outside. This stank up the room for a whole day. But that's a small price to pay because look at how nicely it came out. Perhaps if I ran the laser around the outline over and over again, I could cut it out using the laser, but for now, I just cut it out by hand. And here it is stitched into place on this really cool 5-panel cap that my partner Natalie is making using an old pair of jeans of mine. We thought it would be fun to take some scrap fabric that was near the end of its life and upcycling it to create this kind of limited edition make anything merch. Though I'm not sure if I'll be able to let go of it, so I might just wear them myself. But what's really important here is that the engraved images that the Snapmaker made are super clear on this leather. They create a really nice indented image. I really don't think it could have turned out any better. I'm pretty sure these will look way cooler with the brim attached, but I'm pretty excited about where they're heading. For now though, let's move on to the next unrelated project. I recently learned about the Tagua nut. It's actually a seed that comes from a specific palm tree, the Tagua Palm. And what's cool about this seed is that traditionally it's been used as an alternative for ivory when it comes to carved jewelry and buttons and small little carved items. So that's pretty cool. Now, I don't have a Tagua palm nearby, but I do have a small palm plant in front of my house, and I was wondering if I could harvest seeds from that and pull off something similar using the CNC function of the Snapmaker printer. You might think it's ridiculous for me to expect to get anything from this little palm that would compare to the prestigious Tagua nut, but check it out, I got nuts! Or seeds or something. I'm not quite sure what these things are, but let's crack one open and find out. Okay, so this does seem to be the endosperm inside, but it does look kind of moldy. So I'm not sure about that. Let's try another one. Okay, that's much worse. So let's hope third time's a charm. All right, now we're talking. That nut looks good enough to eat. The next one also looked really good. And we have one more. Nice, all right. So it didn't look very promising at the beginning, but we've got something to work with here. Although these nuts are pretty squishy. So, to deal with that, I thought maybe I could throw these in my filament drying machine for a few hours and have them harden that way. I mean, it's basically a food dehydrator, so that should work. I don't know what temperature to use or anything, so I'll just set it in the middle and leave those for a while. In the meantime, let's swap out the laser head for the CNC and do a quick test cut to see if this thing even works. So I'm just gonna start out with a simple cut using this pointy bit. Once again, we'll plug in this little telephone cable and we'll use the included clamping system to hold down this little piece of scrap wood I've got. So I'll just go ahead and set one of these on each corner here, make that nice and tight. And then I'll also use a ruler to find the center so I can set the origin there. To set the Z height, we'll slowly lower the bit while running a piece of paper underneath. Once that's in place, we can set the origin. And we'll start this quick test file I created. And off we go. Just kidding, I was definitely about to hit the clamp and that would be no good. So luckily I was there to stop the operation and we'll just go ahead and adjust things a bit and start over. All right, so this definitely makes quite a shrill noise. I've actually edited this a bit so it's not as high-pitched as it sounds in real life for you guys, but I'm sure you can get the idea of how unpleasant the sound is. And in general, people have complained a lot about how loud the Snapmaker is, so this is really a workshop machine, more so than something you'd have in your office space, for example, but we are getting a cut, and after a few passes, here's the end result. It definitely isn't the cleanest cut, and I'm not sure how much of that is the machine versus the settings versus using a cheap piece of wood, but at the very least, it's pretty precise. So I think that's good enough to go ahead and move forward with our experiment. But before I do anything else with the CNC, I wanted to create a little sacrificial board to go on top of this aluminum bed. That way we can cut through parts without fear of cutting into the actual aluminum bed here, which would ruin our bit. So what I'll do here is grab another piece of scrap pine, and I'm just gonna take a pencil and transfer over the boundaries of this piece, as well as marking every one of these screw holes so that I can go ahead and copy them onto this piece of wood. That's our template. I'll take it over to the table saw and cut that to size. Of course, you could do this with hand tools as well, but hey, I'll use what I've got. And then we'll go ahead and drill through all those holes for the screws. There was a bit of extra cleanup and sanding, but that's the basic idea. Now we can screw this bed back into place, and then we'll mount our sacrificial board on top of that using these M4 screws on the very corner mounting points. Unfortunately, it seems like I didn't transfer all of the holes accurately enough, so the only way to really get this to screw in was to break off a bit here. Not the prettiest solution, but this is my first trial run, so it'll do for now. I used my ruler to find the center of this piece, and as you can see, I put the laser module back on the Snapmaker because we're gonna engrave a little guide onto here to make it easier to cut things in the future. So back in the Snapmaker software, I'm gonna bring in this grid that I created, and by lasering this onto the board, I'm hoping it'll help us align things and make it easier to CNC everything. So I'm gonna size that down to 100 by 100 millimeters because I know that's the intended size I created for it. And we can double check that the lines of my grid match the lines of the grid here in the software. And that looks good, so we'll just go ahead and set the reference position to center here, which centers the image perfectly over the origin, just like we set it on the actual Snapmaker machine. So once again, we'll process that, generate the G-code, export it, and run it on the machine. So we're engraving a larger image here, and it's pretty detailed, so this ended up taking maybe 20 minutes. And here's the end result. It came out looking really nice and clean. It's aligned really well with the mounting points, and since I screwed those holes into the wood, I can still use the mounting points to hold things into place, like this nut. Speaking of which, let's take a look at those nuts. As it turns out, leaving these in here for one day was not nearly enough, and in the end, they were sitting in here for probably a week before they really dried out and hardened. But just take a listen. Now that's a hard nut. So the next thing I wanted to do was cut these nuts in half, that way I have a flat surface to lay onto the CNC, and I decided to do that with this little hobby saw. It took quite a bit of sawing, so these nuts really have hardened by now. But unfortunately, this first one had a hole going right through the entire center, making it pretty unusable. The next nut also seemed to have quite a cavity in the center. Nut number 3, same thing. So things weren't looking super great, but I thought I might be able to save some of these by sanding away that flat surface until the entire cavity was gone, and hoping there's at least enough material left to make a small button or something out of these nuts. I did have to sand away quite a bit, but in the end I got a few pieces that look like they might be usable. So let's go ahead and set up the CNC. One thing that's really nice about Snapmaker is they've built their product around existing standards. So the little bits here are actually the same sizes as a lot of Dremel bits, which could make for some really interesting experimentation. But for now, I'm gonna swap it out for another one of the bits that was included with the Snapmaker kit. And that's this really detailed little flathead end mill. With that set up, I'm gonna go into Fusion 360 to prepare my little button here. As you can see, it's a very simple file, and well, most of the magic actually happens in the manufacturer workspace. And I will say that the Snapmaker software does come with CNC tools, but for one thing, I'm already familiar with Fusion 360, and I learned that Snapmaker has some really clear and excellent tutorials on how to set up Fusion 360 to export files for the Snapmaker machine. So I would really recommend checking out their tutorial on doing all this work here in Fusion 360 because it is a bit complicated. But in short, I basically created 4 different processes that are stacked together to cut out my button, all using this one little end mill. Unlike the Snapmaker software, in Fusion you can actually view a simulation of the part being cut, which is super handy to make sure that the end mill isn't doing anything crazy and unexpected. So with this simulation, you can see the whole process, starting with this facing operation, which will flatten the top of our nut down and create the thickness of the button that we want. Then there's a quick drill operation to cut the 2 buttonholes, some adaptive clearing to make this little pocket in the center, and then a 2D contour around the outline of that button to cut out the entire thing. And here's the result we're after, which is basically a fully carved button ready to go right off of the CNC. Once things look good, we can post-process this using the Snapmaker configuration file that they have available on the Snapmaker website. Then we can click Post to save that straight to our Snapmaker flash drive to run the operation. So with the help of that guide that I lasered onto the Sacrificial board, I can set my origin right to the center here. And since the nuts that we're carving into are really small, it would be hard to mount them down with those aluminum clamps that come with the Snapmaker. So I'm just going to use the good old masking tape and super glue solution, which is really convenient. To do that, I'll cut 2 small squares of this blue painter's tape. One side I'll stick to the flat side of our nut, sticky side up, and the other piece will go right on the origin of our build plate. One thing I really like about my template is that since it's laser engraved, you can follow the grooves that the laser made to easily trace the lines, so we can still use that reference grid and the center point to place that nut as close to the center as possible. To stick it down, I'm just going to use a small dab of this medium thickness Starbond Premium cyanoacrylate. Probably any super glue will do, but this stuff is really easy to work with. I really like the viscosity of this glue. It leaves a nice perfect glob right in the origin there. And then I can just center the nut and hold it down for 15 seconds or so until the glue starts to harden. From there, I'll run the CNC process that we created in Fusion 360. And as you can see, it starts pretty slow, just scraping off the top surface of the nut. It's not super aggressive, but it does the job, and that's pretty much what I want out of a hobby machine like this. Also, because these are my first CNC projects on this machine, I was playing it really safe, and I probably could go much faster than this. Here's a time lapse of that entire cut, which ended up taking 21 minutes, and there is no built-in dust collection on this machine, so you can't really see much until the very end, but hey, it makes for an exciting reveal. For this first operation, I didn't include the buttonholes because I was a little bit skeptical about those. I just ended up drilling them in by hand. And that actually worked pretty well. There we go. It's a bit thick for the average button, but I could sand that down, and overall, I think it turned out really nicely. So I went ahead and made just a few refinements to my cut, including adding those buttonholes. And here we've got a bunch of time lapses of all the different attempts. Here we've got one of my more successful results. As you can see, that tape method makes it really easy to just pull the button right off, and it's nearly ready to go. Although I was still a bit worried about the fact that this is just some random nut that I got from the palm tree in front of my house, so I decided I should probably give these buttons a protective coating just to make sure that they're strong enough. I went with this clear satin polyurethane by Minwax, and I just sprayed on a few coats on the top, flipped over those buttons once it was dry, and doused some of that on the back as well. And after about 48 hours, here's my collection of buttons. In the end, out of all my cuts, I ended up with maybe 3 of them being successful. I also did another quick test using an avocado pit instead, And while I didn't leave it in the food dehydrator long enough to become completely hard, I still managed to get a pretty nice looking button. And I actually really like the texture that this avocado pit has. It looks kind of leathery. Now, I got a few nice looking buttons, but not enough to make a full shirt or anything. So instead, I asked Natalie to make a nice little pair of trousers for our darling child. I picked my 3 best buttons and sewed those onto the pants, and there we go. I think this turned out super cute. The buttons complement these pants really well, and I'm not sure how they would hold up in the wash, but they do seem like they might work as legit buttons. Wow, what a cute little pair of trousers. So let's go ahead and stick these on my boy. Hello, son. They're beautiful. You're beautiful. All right, so now I've shared some really cool, super practical projects using both the laser and the CNC attachments. So let's finish things off with the 3D printing module. And since I've already 3D printed stuff with this machine for years, I wanted to step things up a level. And in the spirit of the modular style of the Snapmaker, I decided to create my own little attachment for the Snapmaker printer head. So the way this little attachment works is that it snaps on top of the printing module directly above the opening for the filament. Then I bought this colorful pack of Sharpies so that I could stick one in each of these holders. And the idea is that as this white filament passes through, the Sharpies will actually draw onto it and hopefully lead to some interestingly colored prints. So after a quick purge, well, that's a good sign. Let's go ahead and see what happens. So I started off by printing one of my quab puzzles, and the result was more interesting than I could have imagined, because despite just leaving these 3 colors in there, they didn't all blend into one brown color, but rather they created this really complex and interesting gradient. This right here is the result of a blue, yellow, and red marker mixed together. And the subsequent quab puzzle that I printed turned out completely different, using the same exact setup. I was really amazed by this result, because if I just take apart my contraption and lift it up, I can see that the Sharpies are all equally coloring the filament. So you'd expect the result to be a kind of combination of all of them, but not really taking turns as they seem to do. It might just have to do with the markers being loose and kind of jiggling around, and that affecting what gets colored, or even the pigment kind of mixing and getting caught up inside of the print head. While I couldn't figure out the exact mechanic, I was able to swap out markers while the print was happening to get some really interesting gradients. And honestly, I think the randomness and unpredictability of it just makes the results even more beautiful. Here's a time lapse of me printing one of the pieces, and you can see all the different colors I'm swapping out at the top during the print. And here on the right, we have the resulting print, which looks completely different. So maybe you guys can help me get a better idea of what's happening here, because the result was definitely really cool. Here's one where I created these stripes by just intermittently taking the markers out and then putting them back in throughout the print. But personally, I think some of the most beautiful prints are the ones where I just left 3 of the same marker in place and kind of let the randomness take over to create these really subtle, more natural looking textures. Well, these must be some of the coolest Astrolabicons I have printed yet. I really love how that Sharpie blender creates these really cool, complex colors. And the quality of the prints was amazing. I made these awesome custom laser cut cards, some leather printed stuff. Me and my boy have matching pants. I guess I can say my opinion on 3-in-1 printers has changed because this machine seems to do each of its 3 jobs just as well as a standalone machine could. And yeah, the build volume is pretty small, but that just makes it easier and less complicated to keep things calibrated and working well. So I kind of appreciate that, and it's almost a plus if you don't need the larger build space. If you do, well, that's kind of why the Snapmaker 2.0 came out. So I think that printer, it's weird calling it a printer, right? It's a 3-in-1 making machine. Yeah, the 2.0 is basically just an evolution of this, a step up. So maybe I'll get to try that soon, but even this original Snapmaker is super capable, and these were just the first projects I've done using the laser and the CNC, so I can definitely get more complex. I think it would be cool to use the CNC and then laser something on top of that carved pattern. I don't know if you'd call this a review, I just wanted to show some cool projects I did with all the different modules. And yeah, I'll have the Sharpie blender piece available for you guys to 3D print for free on My Mini Factory. Check out links in the description. I'll also put links to the Snapmaker original and probably the 2.0 as well. The Snapmaker machine was sent to me for free by the folks at Snapmaker, but they didn't pay me for the review, they didn't pay me to say anything. I just wanted to share my honest, unfiltered experience with this machine, and clearly it took me long enough. But anyways, I just want you to know I always try to be very direct with you guys and just show you what I did. This is what I did, and I had a lot of fun doing it. All right, well that wraps it up for today's video. If you enjoyed any of my projects, I hope you'll hit that thumbs up button, and we've got some cool upcoming projects, so subscribe if you want to see those. But that's it for today, so until next time, I'm Devin, this is Make Anything, and as always, stay inspired. Ain't that right?